Good morning, everyone. Welcome back for those who were here yesterday for part one. And hello and welcome to those who are joining us for the first time for part two. Today's session is about subsurface strip dispersal systems. And mostly it's going to be for wastewater, not for recycling and reuse. But on the other hand, we will be scheduling one of those for later. The emphasis today is from the regulator standpoint of looking at what to expect during an installation. Later on, we're going to be joined by a couple of my regulators, and they are going to be discussing how we approach that here in Northwest Michigan. But we'd like to hear from you today. If you have a microphone or a webcam and you want to participate verbally as opposed to using the chat window, please feel free to turn that on and be part of the discussion. Most of you, I'm sure, are used to webinars being pretty static affairs where you sit there and are fed slides one after the other and you don't get a chance to participate, and that really isn't the case here. We really want to hear from you and hear what your experiences are. And bless you. Do join us again for part 3 tomorrow, where we will be looking at the how to really review the O&M plan. Most advanced systems require an O&M plan as part of the permitting process. That may not be the case in your jurisdiction, but again, we'd like to hear from you. Just a reminder that part 1 was recorded and the slide set was emailed to everyone. If you didn't get that, please let me know. I'll make sure you do. This session is being recorded, and at the end of the session, you will get the link to the full slide set. Now, most of you can see my wonderful photograph in the top there. I am your moderator for today. I am Dendra Best. I'm the Executive Director for Wastewater Education. And we are at the moment seeking funding to do full closed captioning for all of our programs. Not quite there yet. But if you require a text transcript of today, an actual editable text transcript so that you can import it into a translation or into a text reader, do let me know. The disclaimer here is that we are a public good nonprofit. We provide these events and the opportunity to then attend these events as an educational service. We are an impartial, independent entity, but we do seek out partnerships and resource networks. Our mission is to advance the knowledge and the access to knowledge. So with that being in mind, although we are extremely grateful to Geoflow for partially underwriting today and for devoting a great deal of time into preparing these sessions, our presentation of this should not be construed as an endorsement or as an advertisement specifically for any vendor or any technology. We're going to be showing you a couple of YouTube videos today, and I wanted to set the stage for exactly why this session is so important today. Most of you, if you're on this map, can relate to the dramatic shortage of water in the environment and the ecosystem this year. It's been coming for a number of years now, but it's certainly here this year. You will see that where we are, here, I'm sitting right here in Northwest Michigan, all of Michigan, all 80-some counties are under a drought advisory. We have dramatic agricultural issues here. And came across this link just yesterday, actually, and the drought.gov. I'm going to put that into the chat window for you so that you can have this for later, and also going to put this link into the chat window too. And at the moment, we're going to do a check on how many of you can see a YouTube. Some systems do not access YouTube very well, but this is a short 90-second YouTube video, and it will probably play independently, excuse me, on your screen, or it may open in a new window. And we would like you just to let us know, excuse me, using the green check when the video is stopped playing for you. And we're going into web tour right now. And I'm going to turn my microphone, and would you turn yours off too, Rodney, so we don't get feedback? Please excuse the unwarranted intrusion of the political advertising here. We have no control over that. Okay, I'm seeing that at least one of you didn't manage to see that. Most of you did. So I think with apologies to Suzanne, Rodney, you should be okay to go ahead and show your other YouTube video. Okay, there's a couple of people got issues, but the link to that one is in the YouTube video, and the YouTube link is in the chat window. The main issue for showing that, actually there are a couple of people on the call today. Oh, okay, I'm sorry. I did end it quite quickly there. The main portion of that was dealing with the severe lack of water in the environment at the moment. And the point we made yesterday is that when we come to the reuse of wastewater, or how we design wastewater systems, we have to be aware of the sustainability of them. Do go back and look at this later. When we get to the YouTube video that, okay, sound was a problem. Yeah, I noticed that on mine too, but when we get to the video that Rodney is going to show from NRCS, what I'm going to ask you to do is to let me know when you can actually have finished watching it, because there is a slight delay. I want to make sure that everybody gets a chance to see it all the way through, because depending on your speed, there can be a slight delay on that. And so with that, I am going to move on to introduce our presenter again for today, who is Rodney Ruskin, the CEO of Geoflow. And I'm going to put Rodney's contact information into the chat window. And before we get going today, oh, Rodney has logged out. We have to wait for Rodney to log back in here. If you would please use your polling button, the red X or the green check mark. And the first question here is this subject new to you? I'm just seeing a couple of people that this really is new to you. Most of you, it's not. So my next question, let me clear those answers. My next question to you is, would you like Rodney to address this in more in-depth level this morning? This is going to be specifically looking at installation techniques. And I wanted to make sure that Rodney had feedback for how to, exactly what level to pitch this to today. Okay, that sounds. That's kind of the impression we got yesterday. So, of course, as Rodney seems to have lost his connection at the moment, I'm going to stop the recording until he rejoins.
The YouTube came up the last time. Okay.
Okay, there you go.
Okay.
Go ahead, Rodney.
Okay, let me just go to the next page. Incidentally, I completely blanked out when the YouTube came up on that last recording. My computer froze, which was the reason.
Yeah, I don't think it's a good idea to show that YouTube video. A couple of people had the same issue, so we'll just put the link. We'll put the link into the website for them.
Okay, if other people had the issues, for sure. Okay. David Morgan was going to handle the soils on this in this session, and he had various family problems, which happily are all completely health problem, which is completely resolved. And but what we will do, soils are so important. It definitely needs a complete, at least 1.5 hour session. So Dendra will program an alternative date for that. Okay. The first thing is the purpose of the site inspection. Determine the suitability of the site. Okay. Yesterday, somebody asked a question about these very heavy clays, and sometimes sites just are not suitable. I mean. DRIP always gets offered the worst possible sites, and sometimes they get to a limit that's, you just can't do anything about it. Okay, then you've got to check the area required for the disposal field.
Rodney, can I ask you just to move your microphone a little? I notice people are still having problems, some of them with the clarity of your microphone. And you had adjusted it closer to your mouth a little earlier.
Let me just change this. Oh, that's right. I have an idea. Let's see what this does. Is that any better?
Let me ask the attendants. Is that better? Yes. Talk a bit more, Rodney.
Okay. How does that now?
Like I said, it's fine here, but okay, there you go. Go ahead. I'm sorry to interrupt you.
Okay.
Yes.
Well, at least it's a bit better. So anyway.
Yeah. Do adjust the level on your microphone, on the screen, not on the microphone itself, but on that slider bar in the audio video window.
Do you think down though or up?
Up a little.
Okay. Is that better?
Yes. Okay, much better. I'm sorry. Go ahead, Rodney.
Okay. Check the area required for the disposal field. Okay, you've got to look at the usable area. I mean, somebody might say they've got, 10 acres, and somehow or other you look at the 10 acres, and there's a house covering some, and a garage covering some more, and the driveway, and all sorts of things that. A lake, a pond, and all sorts of things, and before you finish, you've got half an acre, and that is the worst half an acre on the property in terms of soils. So you can't presume that because it's a large area available that it's actually usable. Then you've got to start checking the location of the drip field, which of course the designer should have already done for you, and if required, expansion or replacement area. Always be cautious. If the drip field's filling up the entire available suitable area, you've got no safety margin. Okay, you have to actually visit the site. There's no way you can possibly evaluate the site without physically going there. You've got to look at the factors. We covered some of these yesterday, so I'll go through it very quickly. There's the absence or protection from flooding, the landscape position, the slope, the soil colour and the soil, including the mottles. If there's, if you've got a trench dug open, you can look down and look to see, the depth at which you start getting mottles. The depth to the high seasonal water table, which is usually available from, I think it's a USGS database. The soil texture, the depth of the restrictive horizon, the soil structure, and the available area. These are all factors that you have to look at. Okay, flooding. There can be temporary flooding. If there's very, very heavy rain, very frequently areas get to have temporary flooding, but if it flows over and disappears, it's usually okay. No reasonable chance of flooding, of course, is fine. Rare. Unlikely, but possible. Which happens anyway. I mean, particularly, as we know from, you get weather variations and you get typhoons and monsoons and all sorts of interruptions that we can't do anything about. Occasional flooding under unusual circumstances. Frequent flooding. When it's going to happen very often, he says more than 50% chance of flooding. And shallow water standing or flowing shortly after the rain is excluded from the definition of flooding. So if you've got shallow water standing or flowing during or shortly after rain, that's not flooding, because that will, we presume, flow away. And if it doesn't flow away, of course, then you've got a soils problem. Okay, and we looked at this yesterday. The landscape position is second only to the soil. I mean, in other words, if you have mediocre soil in a good landscape position, it might work pretty well, while you might have mediocre soil in a poor landscape position, and it might not be acceptable. So you have to look very carefully at the landscape position. And I won't repeat what we spoke about yesterday, which what do you call it, isn't working. There it goes. We spoke about all this. Oh, still not working.
What are you looking for, Rodney?
Now it's working. Okay. We covered these yesterday, so I won't cover them again today. Okay. Then we've got the same floodplains as we spoke about yesterday. Obviously, are totally acceptable. And the best areas are here, and down here you might have to put a drainage ditch around it to keep the flooding water away. Okay, as we spoke yesterday, the lower slopes, side slopes and foot slopes, you often have seep lines where the lateral water moves to the surface. Okay. So obviously you've got to avoid those if you're going to get seepage coming around. If it's just water flowing over the surface of the ground, then of course you can put in the drainage ditch and divert it away from the drain field. Okay, this is the best position, and the uplands can often, with the depression here, can often cause a problem because you can get seepage coming across from there. So, but often the very high points are the very high areas. You've got something like this. This can often be a very suitable area. Okay, slope. Okay, when you've got very little slope, the water tends to stack, or to build up higher in the profile of the soil, because you don't have the slope to carry it down. If you've got a small slope, 6 to 12%, in my opinion, in this case is David's opinion, you've got an ideal condition because you've got the water going down and away from the drain field, downhill. Over 30%, you sometimes require design modifications, particularly you want to make the drain field as wide as possible and as narrow as possible along the contour of the slope, which means, of course, that because otherwise the drip line at the top of the particular section is going to flow downhill and interfere with the drip lines below it. So if you have, say, 20 drip lines, one above the other, with 2 feet apart, so you've got, covering 40 feet, then that bottom's likely to get very, very soggy from the water coming down from the top. So typically on this sort of slope, you'll probably only want to have about 5 drip lines in a zone, and then a considerable space before you get into the next zone to allow space for that water from that zone to percolate deep below the water coming in from the zone below. I trust that's clear. 30 to 35%, or even over 30%. You have equipment stability problems. You have stability problems from the point of view of installing, which is one issue, which can be handled by installing by hand, as we'll come to. The other issue is that you have to worry, of course, about soil stability, and you might have soil sliding down the slope. So you'll have to be concerned about that and put in a erosion control netting to control the stability of the soil. But any slope can be handled if you take the right precautions. Okay, what you've got to worry about: freezing, which we spoke about; groundwater separation. Are you going to put in a mound in order to get adequate groundwater separation? Very coarse soils, as well, of course, as very heavy soils, the slope, lakeside and oceanside lots, and maintenance. And we'll talk about these as we go. Okay. There are various sources of information that help, I believe, basically help you in terms of making a decision that an area doesn't look good. In other words, that you have to be very, very careful about going ahead in that area, or even completely exclude it, of course. But you can't approve a site based only upon the information you can get off the internet, because somehow each site is always a little different from the report that you'll get about that particular area. So anyway, the USGS, of course, has got a large amount of information, and when David does his presentation, he'll go into more detail on this. Okay. Well, there was a question asked. So we'll check the notes.
Yes, I'm just keeping track of the polling question here. And the polling question was, let me go back a slide here. Yeah.
Are you conversant with the USGS?
It's about 50-50. Most people are, but there's still a few people that aren't.
Yeah.
So the question was, let's move on a slide here. What we are proposing is, for people who are not familiar with soil mapping services from USGS, is that we can host an application sharing to walk you through that. If you are interested in that, do let me know. Go ahead, Rodney.
I'd like to attend it.
It's a little funky. It can be a little interesting, but yes.
If anybody who's here attending who's a soil scientist will soon work out, I am not a soil scientist. And the one thing about soil science is to sort of understand what a soil scientist is telling you, you can learn in a couple of days.
Yeah.
To get, but to actually make a decision based upon the information is very subjective and needs a lot of experience and a lot of training to make a good decision. It's rather like being a doctor. You can go online and learn all about how to keep your cholesterol down, but it's another matter to do the shots is what to do.
And just to let everybody know that as a couple of people did have some serious issues with showing going to YouTube and showing that video, I've posted the link to the NRCS animation of water movement in the soils to the chat window. I'm going to be posting a couple other links in here. Do take the time to check that YouTube, and you can embed it onto your own websites. It just is a little bit more intuitive than showing you the standard how soils are formed, the platy structures, and that black and white illustration I'm sure you've all seen a lot of times. It's a really good interactive video. Go ahead, Rodney.
Okay, here you can see if you have a trench that you're certainly going to be running into trouble. Here it's about 1 foot, and not much is going to go down below 2 feet. So, but that YouTube video I think is excellent. Okay, so let's go to the next one. And again, here looking at the soil color, you can again see where you've got your really good soil stopping here at 20, I presume. I don't know if that's 20 inches. It doesn't really matter though. And you'll be running into some less permeable layers here and impermeable layers further down. But we'll leave this to David when he gets through to the okay. Red or brown, passing rainfall without problems. Yellow or olive, having some difficulty. Grey, seasonable water table. Black, organic matter due to wet conditions and lack of oxygen. So okay, mottling. Red and yellow mottling includes slow absorption rates. Grey mottling with red and brown indicates high seasonal water table. Black mottling may indicate precipitation of iron or manganese in wet conditions. And pale brown mottling with yellow-brown indicates short periods of saturation. And these, I think, just looking at these 4 categories, you can understand why I say it takes a lot of experience to really look at the soil and interpret what you're seeing, which David has and I don't.
Okay. Rodney, let's just pose a quick question to the participants in the room. If you would use the chat window to let me know, how many of you are concerned about the soil conditions in your locality as far as their applicability to using subsurface drip dispersion systems? Okay, a lot of people are using the green check for saying yes, they're concerned about the soil in their area. I see a couple of people entering. I'm not sure there are suitable sites in our area. And Janice Freer is with the state of Michigan. And coming up, Janice, is a link up with a couple of our Northern Michigan health departments who are going to talk about their installation of these systems. But by suitable sites in our area, are you talking about the mid-Michigan area? And while we're waiting for, yes, there are good sandy soils here. So, and Rodney addressed part of this yesterday. I see Dan Thorell from Grand Traverse County is entering too. And again, his comment is, as long as the site meets our code site criteria, we have several districts and drip systems in the ground in Grand Traverse County. Okay, Rodney, so that gives you an idea that soils are definitely a concern for most of the attendees today.
Well, I think, and this is up to you, but I would even suggest that if you can get David or another experienced soil scientist, experience with drip, not just experience, because there's a big difference between the two. I would suggest even 3 hours to 1.5 hour sessions rather even than one. But this is between you and David or whoever else you can get on board for this. It's really a very complex topic.
Yeah, and just to assure, just to assure the attendees that we are working with David Morgan to do that in-depth soils course of the suitability for subsurface. So back to you, Rodney.
Okay. David, incidentally, is a former regulator, and he is a soil scientist, so he can probably handle this better than anyone for this particular application, for your particular needs. Okay. We're now going to really talk about installation, which is, I think, the main topic for the day. And of course, you've got to install the pump tank, and there's got to be some form of filtration. And then we will pump out, then they're going to have your supply lines and your manifolds, your air vacuum relief valves, then your drip lines, and then your return, in which case it's shown nicely going back to the pump tank. Okay, sorry. As we spoke about yesterday, I prefer that to go back to the treatment plant. Okay. And that's what we'll talk about now, is going through this, what's involved in the installation. I'm not quite sure why this has come up at this moment. It seems to be out of place. We spoke about this yesterday with mounds.
Yeah, actually,
okay.
Rodney, we left that one in for people that weren't in attendance yesterday.
All right. Well, this is. Are any people here today that weren't in attendance yesterday?
Yes.
Yeah. Okay. This is a shallow mound. The same argument could apply to a conventional mound. This is photographs taken before the sand, the covering soil was placed, sand was placed over the drip line. And these are 4 lines, 1, 2, 3, 4, and each 125 foot long. So very conveniently used a full 500 foot coil, and the drippers are only 6 inches apart. So we have 1,000 drippers feeding the sand, so that there's very little distance between the drippers, so we don't need much lateral movement for it to saturate the sand and obtain the maximum treatment, the maximum amount of oxygen contact, the maximum amount of treatment of the bacteria in the soil, the anaerobic bacteria with the oxygen in the sand. And these are monitoring wells, and this is a wetland, and on this particular site, which is in Washington State, it worked perfectly. The fecal coliform count in the monitoring wells was down to 0. And the beauty of this, though, which I'm sure you'll start seeing more and more of them, is that it is a shallow mound. And it's nothing like as ugly as a conventional sand mound. And in this case, I mean, it is going to break out. I mean, there's no question it's going to break out here. And into the wetland, but it's going to be clean water going into the wetland. And if you want to, yeah. This is a regulatory issue whether to approve it. The engineers can only make sure it's clean water.
Yeah.
It's your responsibility to decide whether it's acceptable.
Rodney, there was a question in the chat window which actually relates to that mound image from Percy Johnson, where he was saying that the biggest issue they face in Missouri is seasonal high water table. So with the addition of drip to an above ground mound system, is that going to resolve some of Percy's issues?
Yes, I mean, this is why mounds are used. It gives you the clearance that you need, both from the regulatory point of view and from the point of view of actually getting the treatment. I mean, the sand mounds, particularly if you feed it with drip. I mean, most sand mounds are not fed with drip, and what they call Wisconsin mounds, and they work just fine. Usually, though, unless people are very careful in terms of the ability of the soil underneath to actually absorb the amount of water being put into the mound, they will break out at the foot. But again, if it's correctly designed, it'll be clean water. And going back to the picture before, this is a shallow sand mound, and they're being used more and more frequently, particularly in Washington State, because that's where Scott Jones came from, and he started developing this. And he's getting, they're being accepted there, and they're spreading across the country. There's no point in, you don't have to have a high mound if you're going to feed it the drip with this sort of technology. It really does work very effectively, and in the end, it is not terribly expensive because you save a lot of sand. You don't have to bring anything like as much sand. And this particular mound was being fed with septic tank effluent. This was not secondary treated effluent. This was septic tank effluent, as I said, with extremely good results. And it's easy enough to check on this with the health department in Washington State. They have a lot of hands-on experience if you want to get it from
and just for the sake of knowing, how many people on the call today are involved with health departments for Washington State? Please use your green check mark.
Well, I see 7, 8. Okay. Well, I hope that you agree with what I said and you're not going to contradict me. Okay. Since Roswell took over Washington, I haven't been up there for more than a year. So
Percy has a follow-up question. He's asking anyway, how well that drip field functions using septic tank effluent. And I believe Dan Terrell can actually answer that too, because that's the case in Grand Traverse County. But go ahead. Actually, Dan, do you have your microphone enabled? If you do, you could go ahead and answer that question.
Well, why don't I answer it if Dan isn't responding?
Okay.
I mean, yes, I mean, there's absolutely... carry on, Dan.
Dan, just click the talk button on the audio video pane.
Okay, how's that?
Oh, that's fine. Perfect. Go ahead.
Okay. Well, we have a number of sites that are using drip lines with just using a septic tank effluent. We do require that we have a passive filter and then also a filter on the pump, a Syntec filter on the pump to try to filter out as much material as possible. Although after listening yesterday, it sounds like, because the applications that we've seen, we follow our criteria for soils, but the drip lines were 2 feet on center with, I think, 1 foot intervals on emitters. So after listening yesterday, it sounds like maybe we need to put more drip lines in those applications. But
well, I mean, do you need to? I mean, there's always a trade-off between risk, to capital versus the risk. If you're prepared to spend enough money, you can always keep, get the risk down lower and lower. And I tend to believe that 4 times as many trippers is better than 2 times as many trippers. But maybe that because I'm in the business of selling trippers, so I might have a bias. But
okay. I guess that being said, the ones that we've had in the ground 6-7 years, I think, were the first ones that we've done just with primary effluent, and they seem to be functioning well.
Yeah. No, you've doubled the number of bitters, and that's it's probably been adequate. It all depends again on how marginal the soils are. I mean, if the soils are on the better side of what you I don't know what I can do about this. Let me try moving this.
Yeah. While Rodney is adjusting his microphone, Dan, Percy Johnson, I had a question about, and Percy is located in Missouri. He's asking if you experienced biofilm buildup in your emitters.
Is that a question for me?
Yes, it is.
I have not. We have not seen that, or we haven't had any indication from any of the maintenance providers, inspectors that that has been the case. Like I said, things seem to be functioning well, and I'm not exactly. Maybe this would be a good question for Rodney: is how do you determine, or how do you evaluate the internal drip lines in the emitters to determine if there is any blockage that is occurring?
Yeah, and just to let everybody know that we are going to be covering that in some detail tomorrow in the O&M section. But Rodney, try a voice.
You shouldn't get a biofilm buildup inside the emitter. My company, we use tributyltin maleate, which is a bactericide compounded into the material of the dripper. And our competitors use a compound of arsenic, which they compound into the dripper. And both of us do it, obviously, especially for wastewater. So that should be more than adequate to prevent a biofilm building up inside the emitter. We can talk about biofilm building up inside the tube, but I don't want to make this an advertising presentation, so read our literature.
Okay, Dan, if you...
What I'm concerned about is biofilm building up in the soil. The reason the bacterial and biological mat around the dripper, and that's the reason that I'm saying, hey, put in as many drippers as you can. That's the reason behind that argument.
Okay, go ahead, Rodney.
All right, so this is a system going in. This is obviously the supply line, which is going down to this zone and then to the zone below. And here you've got your manifold and the drip line going up into the field. Okay, so you have to maintain a slope. I mean, here you were saying 1%, but you must have a slope so that this drains. 1% isn't very much, but if that's all you can do, that's all you can do. But I prefer more than 1% slope. But then this is going to go back and drain back towards the pump tank every time you switch off under freezing conditions. Okay? That's pretty straightforward, I think. Okay. Here we see a pretty beautiful site. And as you can see, this is only supplying this one home, so it's a pretty large drip system. And make sure you complete all your filling and grading prior to installation of the drip system. You don't want to start installing and then find there's spots where you have to start filling and grading. If you have compacted areas, make sure that you plow them up prior to installation. Okay, and I think this is fairly straightforward. They're holding contour pretty well, and by the look of it, they've got a slight bowing up on the drip line, so when they switch off, that will drain from side to side without any great difficulty. Okay. You want a minimum of 12 inches between the drip line and any respective layer. Now your regulations might require more. If it's dead flat, that might not be enough. If it's got a small slope, you have to look where that water is going to go. I mean, the water has to go somewhere. If you're in Arizona, you've got one set of problems. If you're in northern parts of the country, you have a different situation in terms of where that water is going to go, particularly in the winter time. Here we've got a lake nearby, and we've got the drip line running this way, so I presume there's a slope somehow or other. Maybe the slope's going this way if we're lucky, and then the water's going to drain away from the lake, and you need to know what's going on down here. That's if you've got a restricted layer. But as I said, soil sciences needs experience as well as the scientific learning part of the process. Trees are wonderful for subsurface drip. First of all, they take up a lot of water, evapotranspiration, and secondly, the roots provide you with a very good medium for the anaerobic bacteria to actually be taken up by the aerobic bacteria in the soil. So it's an ideal circumstances. This is done by the New Zealand Forest Research Institute, who did a test for a municipal effluent, and the idea was to grow, use the poplars, I think, and to grow them in order to feed a paper mill in the large scale. The major project hasn't gone in yet, but it's still being discussed. This is Yosemite West. There's about 50 houses in a settlement in Yosemite, private homes in the park. They were there before the park. They were in private ownership before the park was built, or the park was established or announced. And they're still there, and they pump their effluent up into a forested area, and here again you can see, and there's no problem whatsoever. This system's been working perfectly for years. Okay. You want to mark the four corners of your drip line. In other words, before you start installing, mark off the four corners and do it for each zone. In other words, you want to put a marker in here, and a marker in there, and I have an idea that the zone ends there, and there, and there, and there. Maybe I'm wrong, but that's what it looks like. Okay, so you'll want to put in your markers for each zone. A lot of people will build their manifolds in the shop. They're already set up with 2-foot spacing between the T's, so they can just carry it out and drop it in the trench. Okay, when you're doing the system, we should really go back to that first drawing. Quite a way back, but let's go back. Here. You want these two to be at approximately the same height. Okay. Your supply manifold and your flush manifold should be approximately at the same height. For obvious reasons, and everything else below it will be approximately at the same height, and it will drain fairly evenly down each side. And we're using the word approximately. I mean, you don't have to get out any fancy instruments and start measuring it, but you want them to be visually at the same height. And here again you can see the manifold. And here this one's ready to go off in this direction on the other side. Okay. Drip lines should be installed on or close to contours. Now you do get situations, usually in large systems, usually in very large systems, in which we recommend the use of a slow drain drip line. And so if you've gone off contour, as I explained yesterday, the problem with going off contour is that when you switch off the system, the drip line is full of holes and it drains. And you can set up a vacuum that sucks dirt through the drippers that have already drained, the higher drippers. And this, of course, is going to ruin the dripper. It's going to plug the dripper by sucking dirt back. Sucking dirt back can be as frequent a problem as dirt being brought in from the effluent. And you don't want to keep the pipe full, because there are drippers that will keep the drip line full, and then you have an ideal circumstances for bacteria to grow in the pipe, and you've got a problem with bacterial growth, which will, if somebody shuts off for a long period of time, even a few days, they'll come back and find that they have to flush the system immediately in order to get rid of this growth that has taken place inside the tube. So we have a slow drain dripper, which has actually got a slit in it here. You see that slit there. And when the system switches off, this rubber diaphragm goes down, slows down the drain, and this slit allows the drain to take place very, very slowly. So the water will come out of the dripper and will sort of follow a path like this, and then round there, and very, very slowly go back into the pipe. But it's very, very slow, so that keeps the vacuum from sucking it, but just gently drawing the sand back, sawing the air back into the drippers higher up. Now this is only available on special order, and generally it's not required. I mean, but it's available if necessary.
Rodney, there's a quick question in the chat window from Jim X asking if slow drain is the same as pressure compensating. And as long as my microphone is on, if I could ask Dan Thorell and Scott Kenzlowski and Larry Levengood to get ready to turn your microphone on, please, to talk about this slide. Thank you.
Okay, I'll answer the question and turn my microphone off so I don't interfere. Is slow drain the same as pressure compensating? The slow drain dripper, yes. You have to have a rubber diaphragm in order to do the throttling effect. And once you have a rubber diaphragm, you've automatically got a pressure compensating dripper. So yes, the slow drain dripper is pressure compensating. It's not the same as pressure compensating. The normal pressure compensating dripper is not slow drain. A normal pressure compensating dripper, the flow will be wide open and it will empty quite rapidly. Yeah,
there's a note in there from Kemper saying that in Virginia they've had several systems fail because of sand being sucked back in through the emitters.
I'm going to try. I don't know how to answer this one politically correct. Be politically correct.
Do your best. It is the season after all.
This is Rodney Ruskin's personal opinion. I believe that all our drippers will, eventually all our drippers will be slow drain. It's my opinion. We'll find out as we have more and more of these systems in the field and we have more experience. But my own experience and opinion is that it's a superior technique and there's no reason not to switch all our pressure compensating drippers to slow drain. And if you have circumstances where you have the the sand problem where you might be in the very sandy circumstances, yes, I suggest you contact our office, Geoflow or me, and we will certainly see that you get slow drain drippers for systems where you've got that risk.
Dan Thorell has a comment to Kemper asking if the vacuum breakers failed.
Well, Kemper can answer that one in terms of the problems in Virginia.
Yeah. Yeah, I see. A quick question to everyone.
Vacuum release, then you certainly are going to get sucked back.
Yeah. A quick question to everyone in the room. A couple of people have asked if they can have contact lists for the people who signed up for this class. If you are amenable to that, just let me know. Either email me privately if you would rather not have your information released to everyone else, or if you have no problem, let me know that too. I see a couple of people, yes. Dan and Larry, would you turn your microphones on for me? Hi, Larry. Hi, Scott. Good morning. Good morning, both of you.
Morning.
Let's move on to the next slide here. Part of the reason for our organization hosting this session today is that within Michigan, there are areas where subsurface strip dispersal is gaining popularity and has been installed, and there are areas that are still sort of waiting to see. So we thought it would be a good idea for at least 4 or 5 of the jurisdictions that we work with to talk a little bit about the systems that we're seeing in our area. On the call today, we have our past board chair and current EH director for Northwest Michigan Health Department, which is 4 northern counties, and we have Dan Thorell, who is an environmental health sanitarian with the Grand Traverse County Health Department. He is also my board secretary. And also on the call today is, I said, the board treasurer, Bill Crawford from Benzie-Leland, our district health department. I'm not sure that Bill has a microphone today, but Scott, Dan, take it away, talk about this, and we'll give Rodney's voice a little break here. Go ahead.
Go ahead, Scott.
Okay. We've been using DRIP since about 2007 in our district. We went through a code revision that included some technologies that weren't formally approvable by our code. We endorsed using advanced treatment technologies, and one of the things that came out of that code change was proposals from engineers using a variety of different types of sewage technologies, whether they were secondary treatment technologies or disposal technologies. And our code doesn't specifically address drip irrigation, but there is a section in the code that references using alternative treatments that provide equal or better treatment than what we do permit. So one of the types of alternative methods that we've approved has been drip irrigation for final disposal. And we've seen a variety of different systems, some conventional systems using drip for final disposal and some using pre-treatment or advanced treatment prior to drip irrigation. And I would say a majority of them actually have been on conventional sites where there's other limitations, such as slope or space, as to why they wanted to propose a drip system rather than a conventional tile and stone field. But we've got, since 2007, I'm trying to add up how many I know of in our district, and I'm probably off, but I think we only have around 10 to 15 in our district. We're a 4-county district. We've got a variety of different soil conditions, different hydrological conditions, and it's interesting to hear that perhaps sandy soils provide a limitation that I was unaware of, and that's the back siphonage of sand in through the emitters. Now, our experience over the past few years has been rather good. I haven't been aware of any failures using the drip systems. We did come up with an operational memorandum dealing with some of the design aspects of drip systems, you know, looking at it from a perspective of how do you deal with a conventional system versus an advanced treatment system that's getting secondary treatment, and what differences in the design of that system that we were going to require as an agency. So for instance, you know, obviously it's important to polish that effluent so that it removes suspended solids, and so without the advanced treatment or secondary treatment, what we required was 150% of the storage capacity or tank size prior to pumping to a drip system, just so we can afford a little bit more settling, and the provisions for effluent filters and pump discharge filters prior to the headworks box to filter out as much suspended solids as we can. And like I said, our experience has been pretty good. I don't know of any failures related to the drip systems. We've had some complaints regarding the advanced treatment systems connected to them, but I'm unaware of any that have failed due to the drip dispersal. We do have one very large commercial system up in Emmett County that serves a restaurant, a very large restaurant that sees a lot of use during the summer, and that one is included with advanced treatment system. They have some aeration units in series that flow down into a pump chamber that pumps into drip dispersal, and it's a huge field, and sandy soils. It's in a sensitive environment. It's on Lake Michigan. I think the owners weren't required at that time to put in the system, but it's a restaurant that's been around our area for a long time, and they wanted to put in the best system they can. The restaurant is going to end up in their kids' hands, and they went ahead and proposed, and we approved a drip system, and it's been very successful so far. So, Dan?
Okay. Yeah, I would say a lot of the specific items that Scott addressed is virtually the same here in Grand Traverse County. More or less since about 2006, 2007 is when we first started seeing drip systems being proposed, and more or less in the beginning it was in conjunction with advanced treatment. And since that time, you know, probably a couple of years later, 2008, around in that time, is when some of the first systems, drip systems that we saw that were proposed without any pre-treatment were proposed, and we were a little skeptical at the time, but these were on conventional sites, and we, basically just provisioned it that if there was any problems, they'd have to put in a conventional type system. But it's, some of the reasons that people have really gravitated towards drip have been due to what Rodney was kind of alluding to with having a lower mound, or not such a huge, conventional sand mound in their yard. They didn't like that idea. They wanted to go with something that had a little less profile to it, which you can achieve with the drip irrigation. You can get it down at least a foot. And some of the other limitations that or the reasons that we've seen drip being used is in sites where there's severe slope, and you can't overcome that with conventional methods using traditional pipe and stone type applications. So, and also in areas where people want to keep trees, they have an old growth forest near lakeshore, which we typically see around here with summer cottages, vacation homes, and they do not want to clear cut those areas. So drip irrigation has been used in those applications to preserve landscape, preserve the trees. I know of one site also that we used drip on that was a really challenging site on the Boardman River here, just south of Traverse City. A property owner had a cabin that was on holding tanks because the site where his cabin was located was very high water table site, which is typical along the river. And holding tanks, basically what goes in gets pumped out by a licensed hauler and can be very costly to treat and very costly for the homeowner. So they wanted to put in a system and get away from holding tanks. Problem was that they had no suitable area where their cabin was located. However, they did own property across the river as well. Except this property, there was no access point, direct access point. There wasn't a road going up to it. So they actually got permission from the property owner that was adjacent to this site to cross the property to bring equipment down. And drip irrigation was used in this application not only because of slope issues, but of just bringing equipment in. You could hand carry the drip lines down the hills and get to the site, and they kind of block and tackle a ditch witch down in that area to cut the trenches to put the drip lines in. And they were able to get a secure permit from the DEQ to directionally bore underneath the river and get to the site. And otherwise, if there was not the available technology for using drip lines for this application, there's no way that they could have done any other system. So in that respect, I think it's given people a lot more options for wastewater dispersal. So.
Dan, do you have some installations in without pretreatment?
Yeah, that was one of them actually.
What kind of success have you had on those?
We have not seen any problems. Granted, they've been in for a short period of time. I think the first one was around 2007, 2008 that we saw go in without pretreatment, and we're in contact with the maintenance provider, who happens to be a local engineer, and everything seems to be operating fine on those sites.
Okay, gentlemen, thank you so much for your insight. I think that added some real-life practical experience to the presentation. And if you would turn your microphones off, that would be great. And we will hand it back to Rodney. And just to echo the point that Dan made is that and we'll be talking about this a little bit later in the presentation and tomorrow, is that installation of drip systems really limits the amount of compaction in the area itself, so which is a concern. Rodney, your microphone is making a lot of noise again.
You can just turn on. I know why.
Yeah, it's better now. It's better now.
Okay.
Okay, I'm going to advance your slide for you.
Right, now again, this is the same setting where we've got the irrigation pump. I don't know why it's an irrigation pump. This is, and then through to the I'm sorry, but this is back to front. We've got the water coming that way, and we've got the water coming that way. Well, I guess that's not right. Okay, I apologize. I didn't even see it the first time I've seen it on this drawing. Oh well, the water's meant to be going that way, pumping up. Oh, what they're showing is the drainage. I apologize. Okay. What they're showing here is when you switch off, this is not when it's operating, but freezing conditions below the drip field. So we've got I apologize, so that this can drain back. And here they've got a solenoid valve, so you can open this up so that the water can come back here, down there, and drain back through. The solenoid valve opens when you switch off the pump, When the pump's on, it's closed, so it pumps up, and when it's off, when the pump's off, this opens so it can drain back. And here they've used the throttle valve instead of a solenoid valve. This could be this throttle valve here could be another solenoid valve, or it can be a continuous flush, as it is in this case. In which case, you don't have to. You save yourself a valve and make the controller a little simpler, as we spoke about continuous flush yesterday. Okay, and this is fairly straightforward. And as we spoke about yesterday, we recommend 2-inch PVC pipe, so you can get in a heater if it does freeze for one reason or the other, and so everything now can drain back every time you switch off. And this, in freezing conditions, this is absolutely essential. Dendra, is that presentation I did on freezing available on your website?
Yes, it is. I'll find the link and put it into the chat window for people.
Yes, because we did do one discussion on freezing alone. That anybody that wants it can refer to it. I went into greater detail. Okay, there are various techniques of installation. You can just trench by hand. You can use a trenching machine, you can use a vibratory plow, or you can use a tractor-mounted insertion tool. Most people to date tend to have a tractor-mounted insertion tool, but that depends on how much work the contractor gets. Okay. On very steep slopes, you have no choice. The only way to install it is by hand. It costs a lot of money in labor, but sometimes when this is the only way you can build the house, or in this case, build the club, you have no choice. You just have to do it by hand. Okay. Severe slopes, confined areas. Sometimes you can't get equipment into a backyard. You get some situations where you're going to need a helicopter to get the equipment into the backyard, or wherever the best place is. It's very good for uniform depth if people are competent. It's slow. It's labor intensive. It disrupts the turf and ground more because you're building a trench instead of just a cut in the soil, and obviously you have to backfill. Okay. But it works. The oscillating or vibratory plow. These are standard plows that are used for installing cable. You can rent them virtually anywhere in the country because everybody installs cable today somewhere, whether it's for TV or telephone or whatever. There was a huge amount of cable inserted into the ground. Okay, some of these vibratory plows are designed to pull the cable through the soil. Or if you're putting drip line, do not pull it through the soil. We'll see pictures as we go on forward how to use them, because you'll only stretch the drip line and it will break. It will crack under pressure. Okay, it's fast. It's very easy to do. They actually break through roots very nicely. I mean, this oscillating plow, if you hit a root, it just sort of seems to slice through it. You have very minimum ground disturbance. You don't have to backfill the trench. You have to watch your depth because as the plow bucks, as you go over uneven ground, the rear end can jump up and down a little more than you want it to. It's pretty hard to use on a steep slope because you're putting it on the contour and it's going to roll over if you're on a steep slope. You need a little practice. I've actually used one and I didn't have any practice. I didn't find it that difficult. But maybe I had nice flat ground to do it on. Or maybe the people that called me and set it up nice and easily for me, I don't know. And if you're not careful, you can stretch the pipe, but there's no reason not to be careful. And this is a picture of the standard fiber tree plough, where the drip line will be fed down there and out through there. And as I said, this is set up for installing cable. Okay, and here you see somebody operating it, and you see he is carefully hand feeding it in, so he's got no tension. He's got no tension on the drip line as it's being fed in. And as you can see, the cut in the soil is very, very small. And in this particular case, he's going around a tree, and you can be sure that the roots of this tree, you know, are going right across here, and he's just ploughing through them without any trouble at all. Okay, then there's trenching machines, all sorts of varieties of them. Okay, it's faster. If you have a 1-inch blade, you're only doing a 1-inch trench. You still have to backfill, but you've only got a 1-inch trench, which is not as wide as if you're doing it with a shovel. It's very easy to get uniform depth. It's slow, but it's not terrible. It does disrupt the surface, so you have to backfill, because even at 1 inch you obviously can't leave it exposed. Okay, and this is a typical trenching machine. Just so to see how we are on time, I think should be pretty well okay. I think everybody has probably seen these. Probably most of the audience probably knows more about them than I do. Okay, drip line insertion tool. This is if you're doing a lot of systems, or the contractor's doing a lot of systems, this is the best way to go. It's fast. It's got little damage because it's cutting through with a knife. Minimum ground disturbance. It won't stretch the drip line. You can put it on any tractor. It's got a standard 3-point hitch, I think is what it's called. Okay, and the installation tool is designed specifically for this purpose, and it works very efficiently. There's a few of them commercially available. We sell one. We don't build it ourselves, we buy it. But we sell one, and there's several people that build equipment that sell them. And here you put the roll up, which is all set up for a nice 500-foot roll, standard coil, and you can see the disturbance in the soil is minimum. And this is just hitched onto the back of a tractor. So this is, as I said, but any of the techniques work. There's no, in terms of the end performance, in theory, if you don't have to backfill, it should be better because you've got done less disturbance to the soil. In practice, I've never known anything of any serious consequence. When you first switch on, you might get a little bit more water coming to the surface because of the disturbance if you've done a trench and backfilled than if you've ploughed it in with a very narrow knife. But it's trivial. That settles either way. I wouldn't make any issue about which technique to use. Okay. Did I go backwards there?
No, you go forward. I click onto the next slide.
Yeah. Okay. All right. Here we've got them installing that system at Omaha Beach, which of course was a very large system, and you can see they're 4 up, and they are ploughing around the green. Incidentally, just for those people that might be interested, we've done a couple of golf courses. Golf course superintendents are very, very conservative. Very, very difficult to persuade them to do anything that they've never done before. On this particular project, we never did the greens. And this was on my personal recommendation not to do the greens. I discussed it at length with the engineers. Firstly, most greens aren't level. They go up and down. So you're going to have all sorts of risks with vacuum and sucking sand back. We can't put air vacuum relief valves in the middle of the green. You know, they don't like that. Then these golfers, I don't know, they're not rational people. They go around putting holes all over the green, So we decided that we'll stick to spray irrigation for the greens, but all the fairways and all the tees are done with subsurface drip, with surge effluent coming from the nearby town, which is rather a holiday town, and the hot beach where people come on vacation and have vacation homes and hotels and that sort of thing. But anyway, but you can see how efficient it can be to install 4UP when you're doing a large project. Okay, installing. On the right hand here you've got the plow, and here you've got to set your height. He's measuring the height here, so that he's setting it at 6 or 8 or whatever depth the design records for. Okay, and here we've got a trench that was built before he started, and then he put his plow over the back here, as you can see, into the trench, and started plowing. Sometimes you might need somebody to put their foot on that piece of pipe, or put their foot here, in order to stop it, for it to pull it through when you get started, because otherwise, it's got no force to hold it back until it gets going. Once you're through, 3 or 4 feet, you can take your foot off, because obviously there's enough friction then to hold it. This is, of course, the best way to go, because it keeps your overhead way down with child labor. Okay. This is a golf course tee, where you can see the nice cuts that were put in. You can see it from the back, and here's the trench. And you can see how effective it is and how quickly it heals. It heals very, very rapidly, particularly if you do it in the spring. All right, let's just go through some of the equipment that's needed for a installation. This is a standard PVC slip adapter, and this is a special adapter that glues into the PVC slip adapter, and this is designed to take a standard 1/2-inch polyethylene pipe, which is mostly the standard that's used for drip line. Okay, and here you see the drip line connected to the PVC adapter. Okay, now we're taking that, the manifold is lying here, and he's going to cut it. He's going to cut the PVC pipe and then solvent weld this on each side. Sometimes, as I said earlier, people will build this manifold here with the tees already glued in the shop, and then they will have to take this polyethylene pipe, the drip line, and then shove it in. Go back. And then shove it in there and hook it up. Instead of doing it this way around. It's whatever. It's whatever your contractor prefers to do. To go back there, I actually prefer it if people assemble the manifolds in the shop and bring them out, because it does reduce the risk of dirt getting into the PVC pipe. And again, if you flush everything thoroughly, that shouldn't be a problem, but it takes away one more risk, reduces one more risk. You don't want emitters in the trench, because obviously this trench will be compacted by its construction, and we don't want emitters in the trench. So if there are emitters in the trench, you need to remove them and put in plain pipe to connect up.
Okay, Rodney.
Before you start connecting the flush manifold.
Rodney, there was a quick question from Larry Levengood about emitters. Is there any preference for the orientation, up or down?
None whatsoever. Again, I want to avoid selling, but anyway, you've got to answer the question correctly. Our emitters are circular, and we've got two holes in the emitter. The emitter's got a hole on, let's take this case, if it's up, there's be a hole there, and a hole at 180 degrees. And we don't care which way around the emitter goes, it can go any way you like. The main pipe which is sold in competition to ours, if that's the pipe, it has a dripper. It's not a circular dripper, it's a flat dripper, excuse my drawing, stuck on the wall. And then they have one hole for the water to exit this way. And there they do show some preference whether to be up or down. And I suggest you ask them what their preference is. There's arguments for both sides. If it's up, then of course you have a drainage issue. If it's down, you have a dirt, any dirt in the issue. But it's, as I said, I suggest you discuss that with the supplier. But in our case, we have no preference whatsoever. Okay, this is very, very important. Flush the system before connecting the flush manifold. You've got the supply manifold connected up, you've got your drip line laid out, you've got everything laid out except the flush manifold, and then flush it and flush it and flush it. If you get sand into the flush manifold when you're installing the flush manifold, it doesn't matter because it's the flush manifold. Well, it does matter, but you don't. But it's going to go back to the treatment plant. I don't think the treatment plant manufacturer is going to be too enthusiastic about it, but it's not going to be a big deal. And it's only when you switch on the first time. But you want to make sure that any sand or dirt or PVC filings is a common problem. Little bits of PVC pipe, that you get them all flushed out through the drip line and out before you switch on before you connect the flush manifold. And usually you might, say you've got 6 or 7 lines in the same zone, you might want to bend over the outlet on half the lines or even more, so that they're not flowing, so that the other lines get a very, very high velocity. So you can just look, and if the velocity isn't high enough when they're all running, just switch off a few. You just bend over the pipe and switch it off, and that will stop it and push the maximum velocity through each line, so you really, really get it well flushed. Okay, here you see a typical field under construction, which nothing surprising. Okay, let's go into parts. I am going to do a little selling here, if you would excuse me, but this is technology which we've only had for 18 months and we're getting phenomenally good results, so I do want to mention it. There's all sorts of filters. Now there are disc filters. Several people offer disc filters. And I'm going to go into a little circuitous talk here about disc filters. I personally have never liked disc filters. It could be a personal bias. Disc filters were designed originally to take out inorganic material in suspension. The oldest disc filters I've ever heard of or ever had contact with were used in Spitfires during the Second World War. The British RAF Spitfires used them to filter the fuel, the petrol, for those of us that come from England, or the gas that went into the engines. The same disc filters were used on the Rolls-Royce Phantom 3, as Rolls-Royce built the engines, both engines on the Rolls-Royce Phantom 3 car. This dates from about 1935-36. They were made out of brass, they were hand machined and incredibly expensive. When you have a biological material with a disc filter, the biological material will first deposit here, and then the pressure will squeeze them between the discs. So it's sitting here. And now when you switch off the system, and typically in our situation, you know, the system might be off for 20 hours of the 24 hours of the day. It might only be running for something like, you know, 2 to 4 hours. When it's sitting in there, they've got ideal conditions for the bacteria to grow, and you're growing bacteria between the discs. So I'm not for one moment saying that disc filters don't work. They do, but I just don't think they're the ideal solution for biological material. And on the other hand, screen filters also have their problems, so I don't want to sort of say that the screen filters are the answer, because I can give you another set of problems with screen filters that are pretty formidable if they're not correctly maintained and operated. So they both have problems. We have found that we took our disc filters and we added the tributyl tinmaleate, which we call GeoShield, which is our trade name, but it's tributyl tinmaleate, which is the antibacterial material, to the plastic of the discs. Now, when this goo gets pushed into between the discs, the bacteria dies and no longer multiplies. And we're getting phenomenally good results. And one of the tricks is you run the system and you get the stuff built up here, and a little bit gets squeezed in, okay, while it's running. And then as soon as you switch off, you open the flush here, just very quickly. So any goo that's here on the outside will get, by reverse flow, it's not really cleaning the filter, but it will just get rid of this stuff here, will go around there, down and out. So you don't have this stuff lying on the outside here. So then anything that's trapped in between gets killed, and we've had, as I said, phenomenally good results. These are available from small size for single family homes to multiple banks. And so excuse a little selling, but I think they're a great advance. Now there's all sorts of other filters. There's media filters. These are stainless steel flange sand media filters. This is a system at an airport. I think it's Orlando Airport in Florida. Anyway, it's at an airport in Florida. We're a very, very odd system. They work very well. This is a stainless steel screen filter. Very expensive, automatic self-cleaning, very efficient, very difficult to take apart to maintain. It's a real pain taking it apart to maintain it. But otherwise, it's a great filter. This is the trouble. There's always, you know, there's always a condition on everything I say. Here's another filter of the same type, which is also a screen filter with a rotating self-cleaning, automatic cleaning filter. And this one's a little easier to take apart, but as you can see, the bolts around the top, and you have to pull it apart. So it's not, you know, on a really large system, people are prepared to do the maintenance or have to do the maintenance. It's sort of, they have maintenance of the whole system anyway, so it's not too serious. So again, these filters work. I don't want to be negative about them at all. I mean, they work, and you've got to pick the right one for the right job. The small screen filters, which are very popular for single-family homes because they're cheap, they're easy to clean, they're easy to replace. The problem with a screen filter, as I said, we'll talk about the problems. Most of the screen filters operate from the inside out, so the water comes through here and then out to the field. And under pressure, the mesh of the screen will expand a little bit. So any bacteria slime that's caught in between the mesh gets trapped when you switch off the flow, and it closes and traps that bacterial material in the screen. So even when you backflush, it's very difficult to get it out. So that means in order to prevent that from happening, you need to flush very, very regularly, and you want to have the pressure drop across the filter, across the screen, to be certainly less than 3 psi and probably even less than 2 psi to minimize that problem. But if it's used correctly, designed correctly, it works, which is true of all the filters we're talking about. I mean, then you get headworks. This is a headworks for a small system. It's got 2 disc filters, as you can see here and here. The one is set up to backwash the other with various valves. that are cross-connected, so the one backwashes the other. And these are the zone valves going out to the field, and I think they've got 1, 2, 3, 4 zones. 1, 2, 3. There must be a 4th zone, or maybe there's only 3 zones. 1, 2, 3. No, there's the 3 zones going out to the field. Okay, and this is our return coming back from the field, and this is the supply coming in here, around here, and through the filters. Okay. These are quite common. They're not the simplest thing to maintain, but again, they're disc filters and they work. This is another alternative system which has only got one screen filter, or this can be one of the new disc filters. Here it's got the filter flush through a solenoid valve, so you can open and close this either every cycle or every 2 or 3 cycles, so you don't get that build-up pressure difference across the screen, or you flush out the junk that I spoke about on the disc, on the outside of the disc that I spoke about earlier. And here you have the input from the pump tank, again through a solenoid valve here, and then through the filter, and you've got pressure gauges across the filter, so you're monitoring the pressure difference. There's a pressure gauge which is monitoring the pressure coming in and the pressure across the filter. This is here you can see there and there. So that's the pressure entering the filter, and that's the pressure leaving the filter. Okay? And this is the pressure gauge which is going through there.
Yeah, Rodney, just a quick question. If I was a regulator coming in and I saw this and I was going to be inspecting or looking at this in the process, is there anything here that should be something I particularly need to look at, that should be a red flag, that I need to be absolutely sure that this is constructed correctly?
Well, this type of headworks is bought, both this one and the one before are bought pre-assembled or from a manufacturer. You know, in other words, the contractor does not usually build their own headworks box. Now, can they build their own headworks box? Yes. I mean, in other words, if a regulator goes out and sees this, he knows at once who's built it. I mean, and of course there'll be all the instructions on it anyway. You know, that has not been built by a contractor. And the same applies to this particular box. This is also, again, a box which is supplied as is. So, unless you switch on, you know, until you switch on, I don't think there's anything you really need to look at. Of course, when you switch on, you have to make sure that, you know, that everything's working correctly. But I can't think of anything you really need to look for that the contractor's not going to include. I mean, you know, I'm just saying, I mean, you do get some people, you'll get systems, low-cost systems where you have a manual valve here instead of a solenoid valve there. Actually, let's go back to know how that went on. Whoops. Okay. You have systems where this is a manual valve, and people will come out every 6 months and open and flush it. Is that a good idea with a screen filter? No. What you can do with a manual valve, though, you can just open it a crack so that it flushes continuously. It doesn't need to be flushing at high velocity, but just flushes continuously so that that material that's deposited on the screen or on the disk gets flushed away continuously. That's quite frequently done with a manual valve there. Look, it saves a lot of money. I'm not going to argue against it. If it was my own home, I think I'd go for a solenoid valve. But, you know, one can't argue. There are so many systems out there with cracked open manual valves. I can't for one moment say that they don't work. Okay. Then, of course, there's an expensive headworks unit here, and this has got a flow meter. We've got a flow meter here, which is actually measuring the flow in gallons per hour, as well as having an accumulator. And if you go back, I presume that's back, here you see a flow meter. And if I'm not mistaken, this flow meter is only giving you total gallons, so you have to, you know, take a date and then check, or use a stopwatch. Use a stopwatch to get the flow and measure the flow rate with a stopwatch. It could be a flow meter, I'm not sure, but I don't think so. I think it's measuring, I think it's a standard flow meter in the sense of the total flow in gallons that's gone through the meter. Okay. Now, of course, again, this costs money. These are not cheap. And of course, nothing stops this from being connected with an electric, with a wire to go back, you know, through there, and there's the wire out to the, whoops, out there it's going, I suppose, to the controller, and you can actually be monitoring it. You can be monitoring it continuously again, if you like. I mean, there's no end of sophistication you can go to. And again, it's a cost issue. It's not a, excuse me, it's not a technical issue as much as it's a cost issue. And it's a regulatory issue. You get markets like, and I'm going to pick anybody here from Texas, you get markets like in Texas, no insult meant, that are incredibly competitive. I mean, you know, people battle for $5 on the system and lose the job for $5 on the system. And this doesn't result in good systems. I mean, you know, so people take more and more risks. Now, again, you putting something in one of these mansions in Malibu, well, you know, everything's automated. I have heard of one person who is well known in the movie business who said to the engineer who was involved in designing the system and sold him the system, and he said, Steve, so you can have an idea what it is, Steve, when that alarm goes off, it doesn't go off in my bedroom, it goes off in your bedroom. So, you know, that's when it comes to networks.
Rodney, we're running a little behind here, so if we can move on. There was a question from Leslie that we'll answer after the event.
Okay, I will move very quickly. Okay, this is a much lower cost headworks. Again, these have got solenoid valves. They can be manual valves with bleeding, the same as the discussion before. We can go on through this for days. There's a whole range of controllers, from PLCs, which can be monitoring everything, through to boards, which are much cheaper, but work well enough. But you're not going to be getting it going off in the maintenance man's bedroom, or to be going up in the homeowner's bedroom, or outside in the yard. Air vacuum relief valves are critical, as we had some discussion about back. You have to have good air vacuum relief valves, and you have to maintain them well, which we'll get to in maintenance. And here you've got a Schrader valve, so you can measure the pressure in the field. Here we've got the air vacuum relief valve insulated, which we spoke about under the freezing conditions. I won't repeat that. This is a nice system going in Angel Island in San Francisco Bay. And here we've got the headworks in Angel Island, which of course was hand-built. And these are media filters. These are media filters and 4 zones and 2 pumps, and designed for the job. Okay, and here we've got the San Francisco, again, Angel Island, after it has been in for a year, and it's just beautifully green. If you go in the middle of summer, you'd drive past, here's San Francisco in the background, and if you drive past the foreshore and you look across, you can see a bright green patch on the Angel Island. Well, you know that's where the sewage goes. Okay, there's nothing new. Okay, here's a patent issued in 1888. It's a surface drip system, but here you see the dripper, which is a leaky connection. So anybody says that they invented drip irrigation, well, they must be very old. And the name isn't even Haynes because it goes back, there's even systems older than that. There's also no new water. Okay. 1775, Captain James Cook circumnavigated South Georgia and made his first landing, and he named it after King George. And these icebergs have been breaking off way before 1775. So one way or the other, it just keeps going round and round. Okay, so let's go to the. Okay, yes, we can cover under maintenance. We can cover controllers. Are there any other questions?
Yeah, we still have a lot of attendees. Some of them are having to leave, but if anybody has a microphone and would like to turn them on and ask a question, by all means do. If you have a request for something specific for us to cover tomorrow, do let me know, email me. I put Rodney's contact information into the window there, and we go back to our lead slide. This is our contact information that you got with your confirmation email. And if there are no other questions, we are going to end the recording, but we will be in the room for a little while longer if you would prefer to ask your question here in a couple of minutes. And goodbye.